Welcome to another exercise for the workbook statistics. This time I'm going to talk about how to calculate the different measures of central tendency and which possible alternatives to the classical ways of calculation exist. Our task here is, using the following data set on the age of a group of students, which is given as follows, to first of construct a frequency table and then, based in part on this frequency table, in part on the dataset itself, to calculate the mode of the dataset, the median, and the arithmetic mean. So let's start with the frequency table first. But to make our life a bit easier, instead of directly building the frequency table, we're first off going to take this dataset and order this in an ascending fashion. We'll make construction of the frequency table a bit easier and significantly easier the calculation of the median. So if we're going to order this, we start with the smallest values, so that's here the 20, then always take the next largest still available value in our data set. So that in the end we have this ordered data set from smallest value 20 to largest value 30. This I'm just going to copy here into the next slide. Then I can build a frequency table in a really easy fashion by just using 4 different columns, and in the first column I'm going to put all the values used in the data set. If I say all the values, I'm going to mean if I have 3 times the 20 here, I'm just noting 20. Then the next row would be 21, 23. So I'm just noting the 21s, 21 ones, the 23 ones, and so forth. That's the column on the values. That's this part here. Then for each of the values, I'm going to count how often they are represented in the data set. So I have 3 times the 20, noting a 3 here. Once the 21, noting a 1 here. 2 times the 23, noting a 2 here. And that's about it. So that gives me the absolute frequencies, and if I sum those up, I get the number of observations, which, if I look closely, I can see is 12 in this case. So now I'm going to divide each of these absolute frequencies by the 12 observations. So I'm getting 3 by 12. That's my relative frequency for the first one. 1 by 12. That's my relative frequency for the second. 2 by 12. That's a relative frequency for the third, and so forth. If I did this step correctly, I could add up all of these numbers, and in the end I will get 1 or 100%. So that's the third column. The final column here, the cumulated relative frequencies, I get by simply adding up step by step all the relative frequencies. So I'm going to start with the 25%, I'm going to add the 8.33%, giving me first the 25%, then 25 plus 8.33, the 33.33%, going to add this part here, giving me 50%, going to add that one, so forth, so that it is always increasing in this context, stopping by 1 or 100%. Well, that's the full frequency table we're going to need here. So that's already part 1. So if we continue with part B, with the mode, we can do this in different fashions. Here I'm going to use the frequency table because the frequency table lists directly in this column the absolute frequencies. So I can simply take a look which entry or entries has the largest value. So here it's the 3. I have 2 and 2 here, but the 3 is larger. The value which belongs to the 3 is the 20. So my mode in this context, due to the fact that 3 is the largest frequency, the value 20 belongs to the frequency 3, that my mode will be 20. That's the value belonging to the largest absolute or even relative frequency. This, as in this case, can be unique, but not necessarily has to be unique. So it could be a situation that I have more than one mode. Well, that was already part B, the mode. For part C, for the median, I'm going to use the ordered data set again. And well, for the median, I know that I have two different possible formulas. Which of those two formulas I'm going to use depends on whether I have an even or an odd number of observations. So here I have 12 observations, meaning I have an even number of observations. So I'm going to use the first formula, this one here. So I need the 0.5 times n and 0.5 times n plus 1. N being 12, I get 6 and 7. So the x of 6, x of 7 means I'm going to use the 6th and the 7th observation. That's this part here. So I'll look up in my data set, observation at position 6, that's a 23. Observation at position 7, that's a 25. So I'm going to use both of them, add them up, multiply them with 1/2. So basically taking the average of 23 and 25, giving me a median of 24. And that's about the median. So first I have to check how many observations do I have. Then, well, if the number is even, as in this case, I'm going to take the average of the two values in the middle. If I only would have an odd number, so I would have one single value in the middle of the data set, this would actually be my median. So this also concludes the part on the median. Then we have three alternative approaches to calculating the arithmetic mean. The first one is relatively straightforward. I'm going to use the data set. Doesn't necessarily have to be ordered. And I'm simply going to use this formula, which means I'm going to add up all these values and divide them by the number of observations. So adding up all the numbers here, dividing them by 12, since I have 12 observations. It gives me in the end a result of 24.5. That's the usual approach to calculating the arithmetic mean. There are two alternatives which might make your life easier depending on the frequencies you actually have. So if you have a data set where some of the observations are pretty frequent, so a lot of similar observations present in your data set, then the two alternatives I'm going to present next might actually shorten the time you need for calculation significantly. So what are the alternatives? Well, in the first one I'm going to use, or in both I'm going to use the frequency table. In the first one I'm going to use this formula. This formula simply means I'm going to multiply absolute frequencies and the values. So that's the Ni is the absolute frequencies, the Ai is the value. So I'm going 3 times 20, 1 times 21, 2 times 23. I'm adding all of this up, and then I'm dividing this by the number of observations. So it looks like this. So this part already is a little bit shorter than on the slide before, because I can summarize the 3 20s in this part, the 2 23s in this part, and the 2 28s in this part. In the end, of course, I will get the same result as before. So that's one way to work with a frequency table to get the arithmetic mean. An alternative to this alternative, we're going to see on the next slide. So I'm using the same frequency table, but now I'm going to use this formula. What does this entail? Well, now I'm not using the absolute frequencies, but I'm always multiplying relative frequencies, that's the Ri, with the value here. So I'm getting this value times that one, plus this one, times that one, plus this one, times that one. Doing this for all of these different values, adding all of this up, and already have the arithmetic mean. So no longer need to divide by the number of observations. That's for the simple reason that the relative frequencies already are divided by the number of observations. So here, this looks a little bit longer than the ones before. Will yield the same results. So this only makes sense if you already have like the relative frequencies. Or, well, this is a bit closer to what you have to do to calculate the arithmetic mean for classified data. So if you're used to working with classified data, this might actually be, well, more natural to you than the other versions. So decide what makes sense depending on the data you have present. Here you have like 3 alternatives to go about with the arithmetic mean. And all 3 of them, of course, will get you the same result. Well, that's it. So I hope you enjoyed this session. I say goodbye and see you next time.